So this paper is about probabilistic community and role model for social networks. The author of this paper is Yuhan and Jie Tang, but unfortunately, both of the authors came here with us today, so I will present this paper on behalf of them. I'm Yutao Zhang from Tsinghua University. So I will try my best to make it clear in the presentation, but if you have any further questions, please directly contact the author through emails. So let's get started. Yeah, so there are visible elements and invisible elements in social networks. So the visible elements, they are like users, links, and actions. And invisible elements, they are like communities and roles. So these invisible and visible elements, they interact with and affect each other in many ways. And together, they constituting a complex social network system. For example, the user have closer relationships within one social network and then across different social networks. And whether a user take a specific action depends on both the attributes of this user and the influence of the communities he or she belongs to. So let's take a look at this toy example. So in this social network, there are 3 communities. The links are dense within one community and sparse across different communities. This user, they have different attributes and accordingly plays different roles within the social network. For example, Jessica is a structural role spanner in the social network because she bridges different different communities together, while John is an opinion leader. And users have different kind of actions, such as posting, commenting, reposting, and so on. So whether a user take action depends on its role and the communities. For example, a structural spanner, they tend to transfer messages across different communities. At the same time, most users, they comment on their friends or the users within one community. So with such a complex social network, there are 2 questions the author they want to ask. So first one is, how should we model such a complex system so that we can capture the intrinsic relationships among these elements? And secondly, how do we leverage such a model to improve the performance of different applications, such as community detection and the behavior prediction? So there are many existing works on these problems. However, the result is not quite satisfactory due to the following limitations. First of all, most existing work, they partially utilize the information available on the social network. For example, most work views social network as a static form, ignoring the dynamic actions of users. And secondly, some works focus on a few aspects of the social network, missing a global view. And thirdly, some work, they based on discriminative methods. They focus on improving the performance of a specific issue, such as community detection or information diffusion, without interpreting the nature of the social networks. So in this work, the goal is to propose a unified probabilistic model to model the social network which reflects the intrinsic relationships among these visible and invisible elements of the social network, and it has different kind of applications in many kind of different social networks. So the intuition behind this model is threefolded. Each corresponds to one of the visible elements, respectively. So first, let's begin with links. According to the previous study, the distribution of edges, they are locally heterogeneous. So they are highly concentrated within a specific group of nodes, but sparse across different groups. Besides, each node may belong to several different communities, and whether it has a link to other nodes they might depend on the communities which it belongs to. So based on this intuition, the authors make two assumptions. Each node have a distribution over a communities, and each community have a distribution over the links. And then let's look at the attributes. So in a social network, each node is associated with a set of attributes. And based on these attributes, we can divide these nodes into different groups. And each group can be regarded as a social role corresponding to these nodes. So these nodes with the same role, they have similar attributes. And we assume these attributes are of a specific role are generated from the same Gaussian distribution, and that each node have a distribution over the role according to its attributes. And finally, the actions. So whether a node take a specific action depends on both the community it belongs to and its social role. So based on this intuition, the authors made an assumption that the community that the nodes belongs to and the role the nodes of the nodes have a distribution over actions. So based on these above assumptions, the authors propose a probabilistic generative model called the community role model, or CRM for short. So they use this model to represent a social network. And the complete model can be divided into three components. Each generates one of the visible elements respectively. So the first component is to generate links. For each node V in a graph, they draw a multinomial distribution zeta from a Dirichlet distribution, and draw a phi from a Dirichlet distribution prior. And for each edge of V, they draw a community C of this edge from phi, and then draw an edge E from this multinomial distribution zeta specific to each communities. And the second component is to generate attributes. So for each node V in a graph, they first draw a multinomial distribution theta of V from a Dirichlet prior, and draw a row of V from theta. So finally, these attributes of V, they are generated from a Gaussian distribution. And the last component generates actions. So for each action Y, we first draw a row from a Dirichlet prior. Here, row is a probability of a node taking a specific action. So then we draw a community C for each V from this the multinomial distribution phi, and draw a community C for each user V, where user U is a target of this action. So finally, they draw a row R from this from theta. So this ends the model part, and the authors, they evaluate the effectiveness of this proposed CRM model with the following process. So first, they learn the parameter of the model from real-world social network data, and then they leverage this learned parameters to generate a new network. So ideally, this generated social network will have similar structures with the original one. So with this recovered social network, they evaluate the model by three tasks. The first one is called structural recovery. The task is to compare the difference between structures of the original one and the generated one. So the structural similarity there is quantified by 6 matrix: degree, pairs of nodes, eigenvalues, eigenvectors, clustering coefficient, and triangle participant ratio. And the second task is behavior prediction. The learned parameter rho reflects the probability of a node taking a specific action. So hence, it is intuitive for us to use it to predict users' behaviors. And the third task is used to use the learned parameter zeta to detect the community within one social network. So the authors conducted the experiment on 3 social network data sets. The first one is a co-author network, and the second one is a sample of the Facebook network, and the third one is a subgraph of Weibo network. So in the first structure recovery task, so they compare the proposed method with a baseline method called MAG. So the experiment is conducted by comparing the 6 matrices introduced in the previous slides. So the figure shows the experimental result. The blue line is the original network, which is the ground truth, and the green one is the result of the proposed model, CRM, and the red one is correspond to the baseline method. So obviously, the better result will be closer to the curve of the ground truth. And it is shown on the figure that the proposed method consistently achieve a better result on each one of the matrices. And a similar result can be shown on a Facebook network. And the second task is a behavior prediction task. Since this is a classification problem, so they compare the proposed method with a set of classifiers. So in this experiment, they use co-author and Weibo network as data set, and they evaluate the performance in terms of precision recall, F1 score, and AUC score. So the experimental result shows that the proposed model consistently outperforms the alternative models. And to evaluate the performance of community detection, the authors conducted a case study on co-author network. So they manually set the parameter C as 150 in the experiment, and the parameter zeta learned from the data is being used to generate these communities. And they obtained the probability of each researcher over different communities. And this table shows the researcher with the highest probability over 3 different communities, data mining, computer vision, and the database. So as future work, the authors want to consider more factors that affects network structure and user behavior, such as temporal features. And they also want to try out a nonparametric method to learn the hyperparameters automatically. Okay, thank you very much.